Okay, this is the review for Unit 7. I'm doing Review C. You may not have Review C. That's okay, because the questions are very similar. So here we go. Okay. Number one may be a little different than what you're looking at, depending on whether you have A or B. But the concept is still the same. Here we have, I don't know what that is. Here we have distance from home. You may have total distance, but that means this person on this graph is leaving home, going somewhere, leaving immediately, coming back home, and staying for a while. So that's what the first thing I'm going to look for. I'm going to take the first part of this and I'm going to look for that. Mike went to school and stayed for half the day. No, Mike didn't stay anywhere. See right there, it's a point. He left immediately. Mike left for school, then returned home for his forgotten homework. Possible. He spent 10 minutes looking for it, then went back to school. He got sick and had to go home. Spent some time looking for it. Went to school, got sick, stayed there, got sick, had to come home. Maybe. And you're like, well, wait a minute. Why are these two different distances? Well, he forgot his homework and went back home. So that's a possibility, but let's read them all. Mike is already at school when he got sick in PE. No. We know from this graph, Mike left from home. Mike climbs a small hill, comes right back down. He then climbs another hill up to a cliff. Then he continues up the hill. No, not even close. So our answer is B. You have to eliminate all the wrong answers. That's what you're doing here. You're looking at what the graph is telling you and eliminating the wrong answers. Okay? Number 2. Which of the following real-world situations could best be modeled by the following graph? What do we have? We have somebody staying somewhere, going somewhere, slowing down, going somewhere else, slowing down, then staying somewhere. The amount of gasoline in the car's gas tank each morning for 2 weeks. Now, I don't know about you, but the amount of gasoline in the car's gas tank is going to go down, then it's going to get filled up, then it's going to go down. Okay? So that is completely wrong. The temperature of a pan of boiling water after it is placed on the counter to cool. Well, unless something is wrong with your counter, water placed on your counter is going to get cooler. Unless, of course, your counter has, possessed by Satan. And then maybe it'll, rise in temperature. So that's not right. The height of a plant above ground growing from a seed to a mature plant, maybe, but let's read the last one. The height above ground for a helicopter landing on a hospital roof from the air. Oh boy. Now here's the dilemma we have. These two could be accurate. A plant growing, the height of a plant above the ground growing from a seed to a mature plant, maybe. A helicopter above ground, the height above ground for a helicopter landing on a hospital roof, maybe. So here, this is one where we just have to take a guess. I'll be honest with you. I really like the height of a plant above ground better. That's just me. On a test, if it was something like this, I would accept either one. Because they're pretty close. I can see where this is a helicopter. This is your helicopter right here. It's on the ground. Then it takes off. It flies. And it lands on a hospital roof. I can see that. I can also see this is a plant. It sprouts up from the ground. It grows. And then it reaches its maximum height. So this one, either one would be fine. Okay, based on the information, sketch a graph. You want total distance, so total distance has to go here. And time has to go on the bottom. These two have to be on your graph for it to be right on the test. Okay? Julio travels to Fry's to pick up some much-needed groceries. He purchases groceries and then leaves. So here we go. He goes to Fry's. He's there for a while, right? Then he leaves. Now, total distance, I cannot go back towards the x-axis. On the way home, he stops to get gas in his car. He then arrives at home to put his groceries away. So here he is. He leaves the grocery store. He gets some gas. He goes home. And then he puts away his groceries. There you go. Fry's, you do not have to label it like this. I'm going to say he stopped at Circle K. I don't know. And then he's back home. The point is, total distance always leaves the x, never goes back towards the x-axis. Okay? Okay, number 4. Now, this one is distance from home. Must have distance from home on the side, time on the bottom. Distance from home, I can go back towards the x-axis. Let's see what happens. Alex drove to Walmart to buy a new CD. Drives to Walmart. Alex could not find what she wanted, so she came back home. So she came back home to get her credit card. That makes no sense at all. She drives to Walmart to buy a new CD. She couldn't find it, so she does spend some time there. Then she comes back home to get her credit card. Distance from, she can go back down. She then drove to the mall, which was further, to purchase the CD. She goes further, purchases the CD. She then goes back home. Here's the big thing. See, here is Walmart. Here is the mall. It's further away. Okay, and she can come back home. That's what your graph should look like. Identify the maximum point of the graph. Now, this has to be in an ordered pair format. So I need my x-axis first. The x value looks like it's about 2, so I'm just going to call it, I'm sorry, -2. My y value is 6. There we go. Identify the minimum point of the graph. -2, 9. Sorry, -9. Right here is your minimum point. -2, go over to -2, down to -9. Has to be separated by a comma. Has to be in parentheses. Answer the questions. What's the maximum height of the rock? Height is your y-axis. The maximum height is 8 feet. How long will it take the rock to reach the maximum height? I come down here. I find that it is 4 seconds. Okay. How long does it take the rock to return to the ground? Right here is when the rock returns to the ground. It leaves, it goes back to the ground. Looks like it's going to take 8 seconds for the rock to return back to the ground. What is the domain of the given situation? The domain is what value, the x or the y? The domain is the x value. And the x value is what? Time. The range is what? What is the domain of the given situation? Time. You can put that. The range is height. Now, explain what the domain is in context to the situation. In context, it's not time. In context, it is time, rock, in air. Right? Because we're talking about, we know we're talking about a rock because it says the maximum height of the rock. This is a rock being thrown or flung into the air. So the domain is the time the rock is in the air. The range is how high the rock traveled. All right. That's competency 1. Okay, competency 2, we're talking about how do we change the equation of a line. So what is the equation of a line if the graph is shifted up 1 unit? Up, you add. Down, you subtract. When you shift up or down, you're talking about movement along the y-axis. So this graph right here, the y-intercept is 3. Okay? Doesn't matter what the line is on here. That's your y-intercept. If I shift it up 1 unit, my y-intercept now becomes 4. So I have to rewrite the equation of the line. Negative 1 over 4x plus 4. Shift up, you add 1 to the y-intercept. Shift down, you would subtract to the y-intercept. Or you just draw your x and y axis and figure it out. Given the following equation, what is the equation of a line if the graph is shifted down 2 units? So my y-axis, my x-axis, I am at positive 2. This is where I'm at right here. I'm going to shift it down 2 units. So that means I'm going to subtract 2 from my y-intercept. 1, 2. My new y-intercept is 0, so I could either write y equals 3x plus 0 or y equals 3x. When you shift up or down, you're talking about changing the y-axis. Okay, given the following equation, which equation represents a line that is more steep than the given equation? Remember, now we're looking at what? Are we looking at the y-intercept? We're looking at the slope. This is a tricky one because they give you a fraction for your y-intercept. My slope here is 1 over 1. For it to be steeper, what has to be bigger, the top or the bottom? The top. The rise. The rise has to be bigger for it to be steeper. A, what's my slope in A? Negative 1 over 1. Does negative matter when I'm talking about slope? No. When I'm talking about slope, negative doesn't matter. So A is the same as my original slope. It just goes in a negative fashion. A is not it. 2. Is my top number bigger than 1? That's it. Let's just check the rest to be sure. What's my slope in C? No, that's my y-intercept. Negative 1 over 2, this is my y-intercept, guys. Remember, slope is the number next to the x. Slope is the number next to the x. So, all of these have the same slope as my original one except for B. That's why B is the right answer. Do not get confused by your y-intercept being a fraction. So the correct answer is B, because it's bigger on top. Bigger on top, steeper. Bigger on bottom, flatter. Please remember that. Okay, describe what happens to the slope of the graph of the equation when multiplied by negative 10. Now, here's what you should have remembered. This is what I told you in class. I don't know what is up with this today. If you multiply by an integer, it gets steeper. If you multiply by a fraction, it gets less steeper. An integer is a positive number, negative number. An integer is 0, but if you multiply by 0, that's going to make your slope 0. It's going to get completely flat. So if you multiply by an integer when your integer does not equal 0, okay, your integer cannot equal 0. All right? Your integer cannot equal 0. When you multiply by a fraction, it does get less steep. If you multiply by 0, it's also going to get less steep because it's going to become a horizontal line. So what am I multiplying by? Am I multiplying by a fraction or an integer? Yeah, that's not a fraction. I know you can make it a fraction. That's not a fraction. That's an integer, right? So let's see here. We're talking slope, right? So is it going to start higher? No. What makes it start higher or lower? The y-intercept. So it's not going to start higher. It's not going to start lower. Is it going to get more steep or less steep? It's going to get more steep. It's going to get steeper because I multiplied by an integer, a non-zero integer. So by an integer, and we're going to put here not 0. So when you multiply by an integer that is not 0, you get steeper. When you multiply by a fraction, you get less steep. That's what you have to memorize for this one. Now, you have to look, because if it was talking about the y-axis, and I'm telling you right now, we will, if it's talking about the y-axis, then it's going to be higher, lower. If it talks about slope, it's steeper, less steep. Okay? So, okay, given the following equations, which statement is true? So let's look at the equations before we begin. I know B is steeper. Why is B steeper? Well, my slope is 2 over 1. My slope is 1 over 2. B has a bigger number on top in the slope. That means it's steeper. This is plus 0. This is minus 5. This one starts lower. B is steeper and lower. A is less steep and higher. So look at them and make some conclusions before you read. A is more steep than B. I know that's wrong. B is more steep than A. So A is more steep than B. A is less steep than B. That's true. And A starts higher than B. There you go. A is less steep than B, and A starts lower than B. No, A starts at 0. A starts at 0. B starts at negative 5. Your y-intercept tells you where it starts. Your slope tells you if it's steep or less steep. All right, competency 3, rate of change. Again, you're going to have two things. It takes 18 people to pull a 35-ton bus. 18 over 35. How many people would it take to pull a 140-ton bus? Okay, my weight is on bottom. My people are on top. So you're going to set up a proportion, a fraction, with two things that go together. 18 people, 35 ton. How many people? 140 tons. And then you're going to solve. Facebook message. 35x equals 18 times 140 is 2520. 2,520 divided by 35 equals x equals 72 people. You have to tell me people. If you just say 72, I'm going to mark it wrong. Okay, Tom takes inventory of his closet and discovers that he has 20 shirts for every 8 pairs of jeans. 20 shirts for 8 jeans. If he has 50 shirts, how many pairs of jeans does he have? Shirts are on top. 50 goes on top, X on bottom. 8 times 50 is 400 equals 20X. How many times is 400 divided by 20 equals 20 what? 20 jeans equals X. You have to tell me jeans is 20, okay? Okay, David has a record of wins to losses. That is 3-5. He played 80 games total. How many did he win? Fraction equals fraction. 3-5, this is my ratio. This is wins. 3 is wins, because it's first. Losses is 5, because it's second. 3 plus 5 is 8. Total of 80 games. My totals are on bottom. How many did he win? Wins are 3. So now I do 3 times 80. Divided by 8 equals... How many wins does he have?
30.
30 wins. Have to tell me it's wins. That's correct. Okay? Okay. Jada has a ratio of jazz to hip-hop songs that is 5-3. Jazz to hip-hop. All right? If she has 24 songs total, how many are hip-hop? Fraction equals fraction. Totals on bottom. 24 songs. 8. 5 plus 3 is 8. It doesn't matter where you put the 8 or the 24. You can put it under each fraction. All right, so out of the 8, we're looking for hip-hop. How many are hip-hop? 3x. So this is 24 times 3 divided by 8. How many do you get? That's right, 9 hip-hop. So she has 9 hip-hop songs. Okay, the last competency is graphs. Okay? Predict what happens in year 14 if the trend continues. Year 14 is way out here. On this one, when you have 2 classes, 2 things, when the graph looks like this, charting 2 different categories, you don't have to give me an exact number. What's going to happen? Is this trend going to continue to increase? So I'm going to put enrollment continues to increase. What's increasing faster? Math will increase faster. So on ones like these that look like this, you don't have to give me a number. You have to tell me what's going to happen to the trend. See the word trend? Here you have to give me a number because it's just talking about one thing. Number of push-ups for the age. So, what is the age of a person that can do 15 push-ups? I draw in a line of best fit. I don't like that one. I'm going to draw a line of best fit. When I get to 15, I go up as straight as possible and over. What am I looking at? About what? 81, 82, 85, I don't care. As long as it's close, you're good. It's a prediction. Okay. Using the line of best fit, predict how many jumps a 40-year-old person can do. Age is down here. Go up to your line of best fit. Go over to your jumps. What are you going to get? 40, 41. I don't care. It's all good. It's a prediction. Okay? Predict how old a person who makes 60 jumps. I got to take my line of best fit out a little more. Here's my 60 line right here. I go down. What do you want to make that? 63, 65. We're close. We don't do distributed practice. All right. If you have any questions, please come in and ask. Thank you. Have a good day.